Start recording. Okay, congrats to everybody that's not here, skipping class while the rest of us show up and do your work for you. So anyway, we voted on the teams, and pretty much there's going to be another quiz I owe you too. So, all right, happy Friday to everybody. Let me get my blank whiteboard. I'm going to do one just in general. Epsilon delta, I'm going to do it. I'm going to prove a theorem. So a theorem is a proven fact, if you remember. If I can remember how to write. All right, theorem. What? Why isn't this letting me write? All right, theorem. So theorem, we want to prove that the limit as x approaches a from both sides, because I don't have a particular side, of mx plus b, which, what's that? F of x equals mx plus b. What's the graph of that?
Line.
It's a line. So lines are nice, right? And we should be able to just plug in the point, shouldn't we? Like if we plugged in x equals a, then it would equal ma plus b. So that should just make complete sense, right? That you just plug it in. In fact, for polynomials are nice as well, and you're going to get plugged in. If you need to look along with somebody, Shay, that's fine. So if it really doesn't work, you can go in the back row and see if she'll share. Okay. But anyway, so now how are we going to prove this? I'll do the start. First of all, let f be defined. Okay, what's the domain of f? So if this is f of x right here, that's f of x, then the domain of f is all real numbers. So certainly I'm defined on some open interval containing a, no matter what point a is. A could be 5 or negative a million, doesn't matter. Okay, so we got that. So we're defined on some open interval containing a, or except possibly a itself, but in this case it would be defined at a as well. So we got that. Then the limit as x approaches a of this equals this, if and only if what? If and only if for all epsilon greater than 0. So I'm just say this limit, if and only if for all upside down a epsilon greater than 0, the vertical window, right? There exists, or there is a delta, which is the horizontal window, greater than 0, such that what? 0 is less than x minus a is less than delta, would imply or guarantee that the absolute value of f of x, which in this case is mx plus b, minus L, the limit, which we said on the right side is ma plus b, I'm trying to prove this, would be less than epsilon, correct? Everybody good with that? That's just following the definition. Okay? So if we do that, then that's going to guarantee or imply, let's just work with the right side and just kind of see if we can do this any better. So I'm going to add the opposite. I don't see my color options here today. I don't know why sometimes I get them and sometimes I don't. So that kind of drives me crazy. So you're just going to have to follow along. So plus the opposite of m plus the opposite of b. So basically mx minus ma is going to be, so this is the absolute value of, oh wait, hey, what happens? We got a plus b and a minus b, don't we? Those cancel out, isn't that nice? And then we got mx minus ma, or m times the quantity. If I pull out, factor out the m, it'd be m times the quantity x minus a, right? So I just factored there. So I did kind of 2 steps in one, just to save a little time and space. Okay, so this has to be less than epsilon. Of course, what do I know now? So that implies the absolute value of m times the absolute value of x minus a is less than epsilon. Everybody good with that? Because the absolute value of a times b is the absolute value of a times the absolute value of b. And then what am I really looking for on the left side? I'm looking for a delta where the absolute value of x minus a is less than delta. Well, here's the absolute value of x minus a, so what do you think I'm going to do? Divide both sides by the absolute value of m. Do I need to keep the absolute value bars on there? You don't know that m is positive here, do you? M is the slope, so if I have a line going downhill left to right, m could be negative, so I do need to keep this absolute value on here this time. If we knew it was like absolute value of 2, we could drop it. But m could be positive or negative. Can't be 0 because I'm going to divide by it. Anyway, so it's epsilon divided by the absolute value of m. Now, with that being said, does the inequality change? no matter what m is? No, because you're taking the absolute value of it. So you're just dividing both sides of the inequality by a positive number, right? So m is not equal to 0. So let's assume that m is not equal to 0. I guess part of the theorem, m is not equal to 0. If m is 0, it's a pretty obvious thing. The limit as x approaches a of a constant is a constant. And I could actually possibly show that. But anyway, so what are we going to set delta equal to? Epsilon over the absolute value of m. So set delta equal to that, right? So basically we're going to do on the proof then, and I'm not going to go to a new page yet, but the proof we do the let set. So remember the let set, so we're going to let epsilon be greater than 0, set delta equal to epsilon over the absolute value of m. Then this implies this, and we're going to work backwards. Start with 0 is less than the absolute value of x minus a is less than delta, right? And then replace delta with, just work with the right side of this, and then replace delta with epsilon over the absolute value of m, and do reverse order of the steps. And then you're done. Okay, so I'll let you finish that out on your own so that we can do some other algebraic examples today, since I didn't get this started as quick as I wanted. Let's see, where's clear annotate? All right, so we're good. All right, all good with that? But let's let me just draw another one up. Theorem. The theorem, once again, proven fact. So we just proved that the limit of a line is the value that you get when you plug in the number, right? So if I have here, let me just instead of doing a new theorem, let's just do a quick example. So if I have the limit as x approaches -2 of 3x plus 4. Well, what can I do now? Instead of using epsilon delta on this, if it doesn't say use the formal definition to prove the limit, I can use my theorem, right? I can use my proven fact. So what can I do? I can just plug in, this is a, right? I got -2 for a. I just plug that in for x now, right? So this is how easy limit is. So this is 3 times -2 plus 4, which is -6 plus 4, which is -2, ironically. So the limit and L and A actually worked out to be the same thing here. That was just accident, happen chance, right? All right, which makes sense because if I was graphing 3x plus 4, right, it would look something like that. Plug in 0, you get 4. But anyway, when I plug in -2, I would actually have a height of -2. Which makes sense, right? So it actually lands right on the graph, right? So it's what we expect, it's what we want, but this is limit theory, but we can use that limit theorem now. So we're going to end up with a bunch of limit theorems that end up being really nice. So if I'm not asking you to do an epsilon delta proof, you can use the proven facts and kind of what I call the easy way to figure out the limit, okay? Let's look at another theorem here. If I have the limit as x approaches any value a of some constant, so this is y equals a constant, what do you think that's going to equal? There's no x's. So as x approaches a, what does your constant approach? It stays constant, right? It doesn't change. Constant is constant, right? So it's a number. So why is that? Remember, so that if this is f of x, what does f of x equals a constant look like? Well, if this is your f of x axis, and I'm going to assume k is greater than 0 for initially. So if your height is always a constant, so this is like y equals k, right? It's a horizontal line, right? And if I have a, and I basically, if you pick any epsilon window above and below k, so this would be k minus epsilon to k plus epsilon, right? I can pick any delta is going to work. I don't care what delta you pick. So for a plus delta, a minus delta to a plus delta, if you take all of these x values in here and map them up, what do they all map to? Yeah, K, which actually is like L my limit. So the limit of a constant is a constant. That's how you say that. The limit of a constant is a constant. All good? And then we have some other nice theorems as well. Let's see. By the way, section 1.4, if you did more odds, like I didn't assign a whole lot in that, but like number 15, you actually, I've done that in the past. You actually have to kind of pick between the minimum of two numbers. So that's a little bit awkward. We could do something like that if we wanted to, but some of them are a little harder to come up with what the delta is. But in this case, it's a pretty easy visual graph, right? Limit of a constant is a constant. So we have that theorem as well. So let's just look at an example of that. So example, the limit as x approaches pi of 4 equals what?
4.
Agree? All in favor? Yeah, 4. It's just 4. 4 doesn't change as x approaches pi. 4 is not changing. Okay? All right, what about this? Another example, limit as x approaches pi of 4x. What's that equal?
12 point something.
What answer would I want?
4 pi.
4 pi,
Oh.
right? Keep it exact, all right? So anyway, we just plug, that's a line, right? So 4x is a line, b happens to be 0, mx plus b, right? So we can plug it in. So all good. Isn't this easy? See, I told you this is easy. All you had to do was show up today. I'm glad half of you did. All right, perfect. So the rest of you are showing up virtually later, probably. Not probably, definitely. All right. So, okay, here's the secret code word. What do you want the secret code word to be? Pick a fun word. Freakazoid. Okay, freakazoid is the code word. So I'm going to ask randomly one person that wasn't here today what the code word is from my lecture. And they're going to say freakazoid. Right? And if they don't, then what do we know? Ha ha ha!
I would ask Jared that question.
Yeah. Ask Haas. All right, that's probably a good idea. So, but it could be somebody else too. All right. Anyway, so here we go. So the code word is freakazoid. Yeah, that is the most important thing in your notes. All right, but anyway, now what else do we got? We have here's another couple theorems. So theorems. So there's multiple ones. First one. Well, we're going to let the limit as x approaches a of f of x exists in equal L, and the limit as x approaches a, the same a, that's got to be the same. So I am approaching the same x value for both of these functions, f of x and g of x. That's also going to exist in equal m. Okay. Then what do you think? So we defined the sum of functions, which I know I got homework to get back to you. So sometime before your major quiz, I'll probably get homework back to you. Okay, just keep working odds so you know if you're doing stuff right. Anyway, the limit as x approaches a of the sum of functions f plus g evaluated at x, what do you think that's going to be?
L plus M.
Yeah, because how can I rewrite this? And this is where I really would prefer to have different colors, which I don't see that I have those. Maybe I do. Oh yeah, this is the limit as x approaches a. Look at that, I do. Of f of x plus g of x by definition, right? Which is going to be, I'm going to come up here. This is that equals the limit as x approaches a of f of x plus the limit as x approaches a. Whoa, stop moving. Who did that? I didn't tell you to do that. Limit as x approaches, can you read the red?
Yeah.
Limit as x approaches a, like my hand hovers over something stupid. All right, of g of x, which this is L, this is M, so this equals L plus M. which I'm going to come back, L plus M. Okay, now, the other thing, does that make sense? So if you got two functions that you know what the limit is, then when you add those functions together, you just add the limits together for the limit. But what's key here? The key is that X has to approach A for all of these, the same value, okay? Now, what about, what if I have, I'll use green here. What if I have minus F minus G evaluated at X?
L minus M.
Hey, just because we're on film, like I could put my video on, we could actually do our cheer. So one more yawn, and we're gonna do our cheer. Yeah. Get ready for both your homecomings. You know what I'm saying? Like little rah-rah.
Kind of feels like an empty thread at this point.
Empty threat. Ho, because I'm not making you do it enough. Probably. All right, but anyway, this would be minus, so it'd be L minus M, right? So that's pretty obvious as well. So we have a couple theorems. By the way, and then let's go back. I'm going to try and clear this off. Let's go back and say the theorem. Well, hello. Wow. Holy cow, I need to turn the video on. Like, you guys look sharp city. Wow. Man, I wish I was elected for court at some point. I would have had to dress up once.
Did you go to prom?
Oh, I did dress up for prom, yeah. All right. Anyway, I actually danced with my wife at prom. Didn't really, I mean, I had to check my dance card. We like signed up for dances, and I didn't take her on a date, but I did dance with her there. So that was cool, and then we ended up getting married. So. Well, I assumed I did because I was friends with her. I had to try and dance with friends and whatever. All right, but if I got the limit as X approaches A of F1 of X equals L1, and limit as X approaches A of X F2 of X, so that's a second function, and I could use FG, etc. So if you log in on Blackboard, you should be able to join. Just make sure you're muted, otherwise we'll get a little feedback. L2 all the way down to the limit as X approaches A of F sub n of X is L sub n, then ... So what do you think? Then the limit, then, I'm coming up top, the limit as X approaches A of F1 all the way to F sub n, evaluated at X, what do you think that's going to equal? L1 plus L2 plus all the way to L sub n. And if I happen to put, since where did I see those colors? Here it is. All right, Hannah's in. If I happen to have a minus sign anywhere along the way, what do you think is going to happen? I'd have a minus sign along the way there, right? Pretty simple. So if you know what limits of individual functions are, we could have the limit of sum of functions as well. All right. So then let's see. I want to get into some algebraic ones, but basically so far, quick update, quick reminder. Now that Elijah's in, the limit of a constant is a constant. The limit of a line, you can just plug in the value, right? So we prove that. That's on, you can go back and watch hopefully the recording, which it looks like I can hear, my voice will be on there. All right. And then what if I, here's another theorem. Once again, we got a bunch of theorems. Ooh, this one's in red. Let's get fired up. All right. So let the limit as, we still got that. Limit as X approaches A of F of X exists and equals L. Limit as X approaches A. Once again, same value. Real critical here that we're approaching A for both of these of G of X equals M. So we're going to have that for the rest of the theorems that I'm going to give you. Then the limit as X approaches A of F times G evaluated at X. So the limit of the product, what do you think that's going to be?
L times M.
Is L times M. So the limit of the product is the product of the limits. So this is how I write this. Limit of the product equals the product of the limits. Why do I not say, let's say I say product, how else can you say multiplication besides multiplication? I don't know. Anyway, so this is what I say. Oh yeah, no, we're good. It's a product, right? Answer to a multiplication called a product. So that if I'm going to use this theorem along the way of a on a problem, then I'm just gonna note it with this. I'll do some examples after we get some other ones here. Anyway, so clear this. So once again, same deal. I'm gonna just continue and say what is the so those two limits exist. Then not them. Then the limit as x approaches a, once again, same value of f divided by g, evaluated at x. What do you think that's going to equal? Limit of the quotient. Kaylee, what do you think? You just divide them. It's L divided by M, and that's always okay unless what?
M is 0.
If M is not 0, right?
Yeah.
Whoops. How'd that get? Did that get bigger for you? Because it just did for me. So I need to know if it gets bigger for you. Like something's going on over here. I don't know what's going on. Did the screen get bigger for you? Like my print. So that doesn't happen. So when I was freaking out about it before, like you didn't even see what was going on. It just looks the same.
Yeah.
All right, it's irritating for me. But this is if and only if what? If and only if M is not equal to 0. You obviously can't have the limit as x approaches a of g of x equals 0. Otherwise, you can't do this.
Okay, that one got bigger.
Huh? I wrote it bigger.
Okay.
Like this big, like big. Stop it. Big and little.
Yeah, we're good.
Awesome. Okay. Let's clear this off. That looks like crap. All right. Anyway, and then, so what do I call that one, by the way? So not being done yet, but the limit of the answer to division problem is a quotient. Limit of the quotient is a quotient of the limit. So that's how I notate that without writing out the name of the theorem. So we have limit of a constant is a constant. What was that? How could we do that? Limit of a constant, LK equals K, or if you prefer to use C for constant, because you want to be grammatically correct, I don't care. You can have LC equals C. I don't care which one you do for that. I've done it both ways. So we had that limit of a line you just plug in. In fact, we're going to end up, like I said, a polynomial. You're just going to be able to plug it in. And then what about an exponent? Let's look at this. Let's look at a theorem. So I'm going to try and I don't remember where my colors were. Oh, they're there. And we'll go back in black. Theorem. Once again, limit as x approaches a of f of x equals L. So what do you think the limit as x approaches a of f of x to the nth power, where n is some, well, it could be a natural number like f of x quantity squared, or it could be to the pi power. It doesn't really matter. So n is an element of the real numbers. Of course, if n is 0, then that ends up equaling what? What's anything to the 0 power? 1, as long as it's not 0 to the 0 power, which is indeterminate, right? And then that'd be limit of a constant as a constant, so that'll end up being 1. But it'll all work out swimmingly well, even if n equals 0, because this is going to equal L to the nth power. Make sense? Yeah, you got a little pressure on you, buddy. Like they're saying that you're playing some good team from, no one cares. Go beat them, okay? So anyway, UNI is already going to win. We know that. The rest is iffy. Nebraska is absolutely going to win. We don't even know who Iowa plays because no one cares. And you guys picked Iowa State, didn't you?
We can vote. We didn't pick
Do you want to vote? Well, we can vote on that because, you know, Hawkeye fans are very vindictive and they don't like success of other teams that are local. They would rather have some stupid-ass Texas team win. I'm sorry, is that on film? So anyway, your teams this week are UNI, Kemper, Carroll, Michigan State for some stupid reason, who will lose to Nebraska, and that's a straight up quiz bet there. And who'd you pick? So you get Iowa because we don't know who they play, and then Iowa State of Baylor. Who wants the Clones? Who thinks Clones will win?
Good Baylor. I have no idea.
Is this just straight up? Whoever is winner, just picking a winner chicken
Just
dinner.
go Iowa State. It'll be Iowa State.
Okay, who's picking Iowa State? We got, okay, the majority of the class. You get Iowa State. All right, I'll circle that. I keep record of it. I already owe you one quiz. What do you got to lose? By the way, I can't say limit of a power is a power. I can't say power to limit or limit of the power is a power to limit. I can't do that because I already have LP equals PL for product, right? So what do you think I'm going to do for this one? Yeah, limit of the exponent is the exponent of the limit. Pretty easy, right? So let's look at an example of this. I do want to look at an example of this theorem. Once again, all of these theorems have that the limit of as x approaches a of f of x exists and equals L. Get bigger. Thank you. Oh, wow, look at that. No, it's not letting me write. But let's look at an example. Wow, that is really bold. The limit as x approaches 2, oh, Shay, you're going to do this one, of x, yeah, x to the 10th power, like I picked on you. I got to equally pick on both schools, right? We're all in this together. It's like High School Musical, Professor Ryle style. Hey, man, if you can, you're senior, like everybody but Michaela's a senior, right? Like if you can watch all 3 of them and not cry during High School Musical 3, let me know. And if you can, then like a year from now, you can't. Like you will cry. Like it's emotional. It's gut wrenching. All right, but anyway, what is this, Shay? 2 to the 10th, right? What's that, Shay? We've already been over this. 2 to the 10th power. Double 2 10 times. Maybe you take 2 to the 5th and square it. 32 squared. It's 1,024. Thank you for playing. So you should pay attention to what we had before. It's 1,024. All right. But anyway, I can write this as, if I want to show my work on this, I can say, hey, that's the limit as x approaches 2 of x, quantity to the 10th power, because of y, the limit of the exponent is the exponent of the limit. Right? And then this, what's this one? As x approaches 2, what's x approach? 2. So it's 2 to the 10th, right? Why is that? Well, all right, so I will give another theorem. That's a line, right? Y equals x is a line. So you could say line. You know, I could say line. And then somebody else says, whose line is it anyway? And then I make some joke because that was a comedy show. But anyway. All right, so what else could I do? I could say the limit as x approaches a of x. As x approaches a, what's x approach? A. So I call this the identity. This is the identity because really it's the y equals x line. So the graphical proof of that, if I've got y equals x, and here's a, what's your height? So this is f of x equals x. What's your height? It's a. So whatever your epsilon is, you can pick the same delta. That makes sense? All right, but anyway, this is the identity. So instead of saying line, I usually put ID, like for identity. Okay, all good? So what do you think all this ends up doing? Oh, I got one more. I'm going to clear the annotations. And then here's another theorem. Man, really bold. So now we got the limit as x approaches a of the nth root of f of x. What do you think this is going to equal? It's going to be the nth root of L. Okay? As long as you can do it, right? Like I can't take the square root of -2, right? So if it exists, right? So that is a little proviso here. And why is that? Because I can write that as the nth root of the limit as x approaches a. By the way, why can I write it like this? This is actually has been proven by me or others or in your book, and we know that that's L. So it becomes the nth root of L. So let's look at an example of this quick so I can get some algebra stuff done today. Whoops. So example, if I have the limit as x approaches -2 of the cubed root of 8x plus 8. What's that equal?
Two.
So what I got to do? So this is going to equal the cubed root of the limit, right? Because limit of the root, LR, equals RL. Limit of the root is the root of the limit. We okay with that? X approaches -2 of 8x plus 8. If I plug in -2 here, this is a line, right? So this is a cubed root of -16 plus 8 is -8. And why? Because that's a line. And n, which is negative. Right? So ironically, A and L end up being the same here. Well, L of the L in here, so it's a different L. Limit, the limit. The L in there is not -2, it's -8. So that limit was -8, but the limit of the whole thing is -2. All good? Just another ironic happen chance that A and your final limit are the same. All right, isn't this easy? So what do you think is going to happen? So here's a theorem. If I have a polynomial, if I have a polynomial, so what I used to do is make you step it out. Yeah, let's not do this theorem yet. Let's step it out. Let's look at an example. See if we got time for that. So if I look at an example, if I've got the limit as x, oh, you sucker. Get where I can see you. All right. No, I can't write. So example, if I have the limit, now it's not bold. Where'd my bold font go? Limit as x approaches 2 of 3x squared. Oh, you're killing me. 3x squared plus, like I don't know what my arm is hitting that is changing this on my screen. Plus 2x minus 5. So limit as x approaches 2. Everybody see that okay on your computer? Okay, so what I got to do? Well, there's a whole lot of shaking going on here, right? By the way, I never said the limit of the sum is the sum of the limits. We had that theorem. That's going to be LS equals SL. Limit of the sum is the sum of the limits. And limit of the difference is the difference of the limits. LD equals DL. Makes sense? So when you're taking notes on your own, you can put those in there as well. But anyway, we're going to do that here. So what's the first thing I can do? I can say that this is the limit. Can I split it up with the plus and minus signs? Limit as x approaches 2 of 3x squared plus the limit as x approaches 2 of 2x, right? So that's the limit of the sum is the sum of the limit. LS equals SL. Limit of the sum is the sum of the limit, right? And then minus the limit as x approaches 2 of 5. And that's limit of the difference is the difference of the limits. Instead of writing lines for that, I'm just going to do those together because it's plus or minus along the way, right? So I'll just know. Everybody okay with that from our initial theorems? That was probably before you two showed up. Okay. But anyway, so we're good there. So not bad. By the way, do I know what any of these is? By the way, whoa, don't do that. I'm going to change colors, I think, hopefully. Do I know what any of these are? Do I know what the limit as x approaches 2 of 5 is?
5.
Why?
Because it's the constant.
Limit of a constant is a constant. So LK equals K. Limit of a constant is a constant, right? Do I know what this one is? Somebody else. Gracie? It is 4. Why?
Because you just put the 2 in for x.
Why? Why can I do that? multiple reasons that are correct, but a whole lot of reasons that are wrong. Gracie, do you want to help him out? Like he gave you the answer.
Product rule.
Limit, yeah, limit of the product. So that's one thing. Stop it. Limit of the product. Quit it. Like, can you let me read? I don't understand. Like when it blows up on me, like I can't write. So, but I guess from now on, you all have to show up for class because it's pissing me off. Drawing, come on, drawing. Limit of the why is it not letting me write? All right, so LP equals, limit of the product is the product of the limit. LP equals PL, right? All right, so this is taking me off. Anyway, so that's one reason. What's another reason that I could just plug in the 2 there? What else is it? It's a line. Guess what else I could have done? I could have kept plus 2x minus 5 together as a line and then just plugged it in and said line rule, right? Because since I said you could do that. But I want you to all do at least one in excruciating detail, like with a polynomial. And then with a polynomial, which this is a polynomial, right? It's a nice smooth curve, no sharp turns, no holes, rips, tears, jumps, asymptotes. It's defined on all real numbers, right? We're going to be able to just plug it in at the end. But anyway, for that one, limit of the product is product of the limit. So now we got the 3x squared on top. So everybody going to remember somebody got this written on your paper before I erase it, like what the function is? Okay. Whoa, where'd I go? Clear? So, and then, see if it lets me write this time. Come on, get back up. So, are you freaking kidding me? What is wrong with you? I don't know. Clear? Draw? What? Well, I'm getting irritated. What can I do with the 3x squared?
Limit of exponents. So
Well, yeah, but before that, I can do limit of the product is the product of the limit, right? So it'd be limit as x approaches 2 of 3, right? Times limit as x approaches 2 of x squared, right? And then on the second one, I can use exponent rule. All right, so here, you get a, hi guy, oh, hi, hi. The code word is freakazoid. All right. So we had the first one. Ooh, I like this better. Limit as x approaches 2 of 3x squared, right, is what we had for that one. So that's limit as x approaches 2 of 3 times limit as x approaches 2 of x squared. And because limit of the product is the product of the limit. And then what can I say here? This one equals what? 3, because limit of a constant is a constant, right? And what's this one equal? So times 2 squared, because limit of the exponent is the exponent of the limit, right? Which is 4. So 3 times 4 is 12. So this one is 12 plus, what did we have? We had in blue. The word of the day was freakazoid. All right, we missed that part. It was really cool the first time. Anyway, so here we go. Hopefully you can see this. I got to get where. Can you see it?
Yeah, there's a separate.
Like I want to make it big. Like I want to see me. Like where'd I go? I'm tiny little mini me. All right. So anyway, so I got 12 plus 4 minus 5, right? From what we had that I actually could write on there. That's 16 minus 5 is 11. All right. Now let's just go back and say what was our original problem? The limit as x approaches 2 of 3x squared plus 2x minus 5. This is a polynomial. So if it's a poly, so I can just plug it in if it's a poly. So we're going to have a theorem. So this is going to be 3 times 2 squared plus 2 times 2 minus 5 because polynomials are nice, which ends up being 11. And we can just say it equals that because of poly. So that is another theorem. Limit as x approaches a of f of x. If f of x is a polynomial, you just plug it in. Equals f of a, right? So if f of x is a polynomial, then it equals f of a. So that's all in your book. There's some algebra ones too. If I get some extra time, I will do some algebra ones because what you have to turn in 1.5, I haven't covered some of those yet. There's some awkward functions that we got to do some manipulation to. So we'll do that. I will try and do those a little bit on video if I can. Otherwise, we'll tackle it Monday. And from the looks of it, most likely, I already owe you 1 quiz. I'd hate to owe you 2. So may all your teams win unless they're playing Nebraska. All right, bye.